Today we're looking at the Greek symbol sigma, and it means the sum of. Now you basically know all the formula already because we've done them. We are just going to learn how to interpret this in today's lesson. So here we go. Here's the example. Now here we have the sigma, which means the sum of. Now this part below sigma, that is the first term where the adding starts. We have to calculate its value first, then we know what A is. So this basically is the place where we start to add from. Okay, so we are starting from term 1, and this value on top of the sigma, that 10, that is the last term that we will add. So this basically means the sum from term 1 to term 10. Okay, got it? And now this part in front of the sigma, or on the right side, that is usually the general formula for a series. Now if we look at this one, it is basically 3n plus 2. Now this is the general formula for an arithmetic series. So we want the sum from term 1 to term 10 for this arithmetic series. Therefore, we will use this sum of formula or this sum of formula. You can remember that, right? Okay, great. Now, let's look at another example. How about this one? Here we have the sum from term 3 to term 10. This is basically 8 numbers that we are going to add together and not 7. So please pay attention. We are going to get the sum from term 3 to term 10. Now, that means that it's this term that is included. So from 3 to 10, we are going to add 8 numbers together and not 7. Then, here's the general formula. And this is 2 times 3 to the power of n minus 1. This is the general formula for a geometric series. So we are going to get the sum from term 3 to term 10 for this geometric series. Therefore, we will use this sum of formula. Got it? Okay, how about the last one? Now, here we have the sum from term 1 to infinity. And the general formula is 9 times minus a third in brackets to the power of n minus 1. Now, this is the sum from term 1 to infinity. This is a geometric series where the constant ratio is a value between minus 1 and 1. So this is a convergent geometric series, and therefore we will use this sum to infinity formula. You got it? So we can easily see what we need to use, and let's go and look at an example. Now we are going to calculate the sum of the third term up to the 18th term for this specific sequence. Now I don't recognize this general formula at all. It looks like a geometric series, but it's not, because otherwise this should have been k minus 1 and not k minus 2. This is not a major issue. The only thing that this stops us from doing is choosing our sum of formula right away. But we are going to follow the same steps anyway. So let's have a look. We want to know what is the value of term 3. Okay, so we're going to take this 3 and put it into k's place. We do this on our calculator and we see that term 3 has a value of minus 6. Then we get the next term in the sequence, which is term 4. We put 4 in k's place and the answer is 12. Then we do the next term in the sequence, which is term 5. We put 5 in k's place, there it is. And then we do this on our calculator and we get an answer of minus 24. Now usually 3 terms in a row is enough, because now we can easily see that this is a geometric series, because 12 divided by minus 6 is a minus 2. Minus 24 divided by 12 is a minus 2. So our constant ratio R is a minus 2. And the place where we begin to add up from, which is A, and the value is minus 6. So A is a minus 6. Now, because we're adding a certain amount of terms, and this is a geometric series, we make use of the following formula. And there it is. Now, in the place of n and n, I'm going to put the value 16. Now, why 16? because we're going to add 16 terms together from term 3 to term 18. And remember, it includes term 3. So if you're unsure, you can do the following. You can simply say 18 minus the 3 plus 1, and that gives us n's answer of 16. So there's the 16 as well as there. Okay, and in the place of a, we can put minus 6 because that's the place where we begin to add up from. And then in the place of r and r, we put the constant ratio, which is minus 2, and there they are. And now we simply do this on our calculator, and we can see that the sum of these 16 terms is equal to 131,070. And that is all there is to it. See you next time. Bye.